Next, let's look at question number 12. A fuel tank has a capacity of ChExQ12. It can be loaded with either hydrogen or methane. Some information about the gases is given below. Hydrogen with density and its heat of combustion. Methane, density and its standard enthalpy change of combustion. Okay? Which gas should be loaded to release a larger amount of heat? And you need to explain your answer. Now look at the table. Of course, we need all these data, okay? It is the kilojoule per mole of hydrogen, per mole of methane. In other words, first of all, we need to calculate the number of mole of hydrogen and methane contained in this volume, in this container. Now, this container is actually equal to 15 dm³. Can you follow? 15 dm³. Divide the ChExQ by 1000, then you can change the unit ChExQ to dm³. So, what do you need to do next? Now, by using the density, first of all, we need to calculate. First of all, in this volume, mass of hydrogen is equal to its density times its volume. Can you follow? You may look at the unit gram per dm³ times dm³. dm³ type over dm³ is cancelled. That means you are calculating the mass, which is 1.3485 gram. Understand? Gram, that means you need to calculate its number of mole. Number of moles of hydrogen is equal to the mass of hydrogen over molar mass of hydrogen. Okay? 0.674 mole. Next, refer to this value, you can calculate the amount of energy released. Amount of energy released okay, is equal to times the number of mole, which is 193 kilojoule. Understand? 193 kilojoule of energy is released when this number of mole of hydrogen is burnt. Use the same method to calculate, first of all, mass of methane in the container, which is equal to its density times volume. Volume is 15 dm³. (9.84 gram). How many mole? Number of moles of methane is equal to the mass of methane over molar mass of methane. Next, you need to refer to the heat of combustion to calculate the amount of energy released. Amount of energy released is equal to 890.4 times 0.165. 578 kilojoule. Now, in other words, for the same container, okay, amount of energy released of methane is larger. As methane releases more energy for the same volume of the fuel burnt. Therefore, the container should be filled. It should be used in the fuel tank. Do you understand? Okay.